Hello, my name is John.
My name's Leilani.
My name is Maria.
And my name is Noelia.
And this is our presentation on twin prime conjectures.
Just to give a little background on the twin prime conjecture, the first statement of the conjecture was by a French mathematician named Polignac, which is why it's also known as Polignac's conjecture. The twin prime conjecture states that there are infinitely many twin primes that differ by 2, as long as the pair is greater than the pair 3, 5. It must be a multiple of 2 and a multiple of 3, and therefore it would also be a multiple of 6. This shows that any pair of twin primes greater than 3, 5 can be expressed as 6n minus 1, 6n plus 1 for some n. As the numbers get larger, it's just a fact that it becomes more difficult to find twin primes, just because the gap begins to increase between the twin primes itself.
Mathematicians Daniel Goldstein and Cem Yildirim released a paper titled Small Gaps Between Primes in 2003. It established that there exists an infinite amount of prime pairings that have a small difference between them. But in their first version, it was inaccurate. And in 2005, with the help of Janos Pintz, the proof was corrected. In the proof, there is an average gap between prime numbers of natural log n. They showed that there exists prime pairs separated by less than epsilon log n, where epsilon represents any fraction of choice. This falls short from proving it, since n can be infinitely large, and it cannot be proven since the overall size is it cannot be proven that the overall size is decreasing since n is so large. But they did show that if the Elliott-Halberstam conjecture is true, which hasn't been proven yet, that there's an infinite amount of primes that differ by less than 16. Mathematician Yitin Zhang developed his proof based on the work of Goldstein, Pintz, and Yildirim.
The mathematician we explored, or another mathematician we explored, was Yutang Zhang. He was an unknown professor from the University of New Hampshire and became famous through his proof known as bounded gaps between primes. What is interesting is that his proof is based on pre-existing proofs, such as GPY, as stated before, and the Bomberi-Van Grove theorem. Through this proof, he stated that there's an infinite number of pairs that are separated by a number n that is less than 70 million. This is considered a huge breakthrough, since there was never an upper bound that was found within the infinite differing twin prime pairs. A large component of Zhang's proof was Bomberi-Van Grove's theorem, which was a method that involves sieving. And sieving is a process of filtering out numbers that are not primes, that are divisible by primes, such as 2, 3, 5, and etc. For example, numbers divisible by 2 would get filtered out if they weren't primed, and numbers divisible by 3, and so on. In addition, if the numbers were already filtered out, then the sieve would continue on. Zhang's proof used a sieve that he modified that allowed him to get bigger prime numbers, which revealed to him that there is a bound in between the infinite pair primes, which is coincidentally less than 70 million. And Zhang's proof focused on sieving out numbers with large prime divisors too.
Terence Tao is also an exceptional mathematician who also approached the unsolved twin prime conjecture, where capital N is any large number and lowercase n is a randomly chosen number from 1 to capital N. Terence took an approach to the twin prime conjecture by using a random model that makes any integer from 1 to n have an equal probability of being prime. Terry observed the probabilities of n is prime with n being even and odd, and n plus 2 is prime with n being even and odd. Terry's argument by assuming these events are absolutely independent was found broken. Terry improved his argument on the twin primes by assuming that the events n is prime and n plus 2 is prime are conditionally independent relative to the parity of n. As he began to add more structure, he found the probabilities of both cases being even and odd. and as he began to notice, he added more structural information to his original argument that the predicament count of twin primes began to converge to a limit, which is known as a twin prime constant. In the end, arising from the prime number theorem, there is no structural pattern in primes. Terence then concluded that the primes behave in a pseudo-random fashion once all the structural information is taken into account. But pseudo-randomness in the primes is not enough to prove the conjecture, because there might be other structures that could further distort the twin prime count.
I always knew mathematicians put a lot of hours into their work, but after researching the work more in depth, I have a lot more respect for them than before. Mathematics is an interesting yet complicated subject. There are so many different possible ways to get the same answer. Mathematicians spend hours developing new principles, knowing that there is a possibility these new principles may not actually be proven. It requires a lot of dedication and hard work, which is why I see mathematicians differently now.
Going over these conjectures, especially as a group, showed me that mathematics is different than what I thought it was. Mathematics is collaborative. It is about mathematicians working together to find solutions to conjectures. Even if a complete answer wasn't found, someone can always come back to any prior research or find a finite solution. I see mathematicians differently now, seeing the amount of time and work they put into research, collaborating with other mathematicians to fine-tune their solutions and work together in research.
The twin prime conjecture really interests me to research. I found many other great mathematicians who approached the conjecture, but Terence Tao was when I understood more.
As I researched on Yi-Tang Zhang's approach to the twin prime conjecture, it was super interesting to go in depth into the pure math aspect in exploring such conjectures, including the Colette's conjecture. This project goes to show how we only scratched the surface of math. However, there is still so much more math to explore. Overall, this was a fun project and experience to dive into. These are our sources, and thank you for listening.